Okay, here's the first example. We need to find the nth term of this linear sequence. 6, 13, 20, 27, 34, 41 and so on. So firstly, I know it is linear because this is happening every time. If you couldn't do that, as in you don't have a constant difference between the numbers, you do not have a linear sequence. So in practice you're going to have sequences that are linear, non-linear, have other rules. If something like this is happening, you can do this. Now, a very simple way to find it. Now, the plus 7 means 7n, right? Then all you need to do, I should have left a bit more room. So if I have 6, 13, 20, 27, 34 and so on, I want to know, when this is the first term, this is u1, u2, u3 and so on. I want to know what is u0. So, as in, if n was 0, what would un be? u1. So actually, if you're adding 7 this way all the time, if we take away 7, that's going to be minus 1. And it just goes in there. And that is it. If you want to know why it works, I mean, there are different ways to prove it, but if you just think about the link between this and a graph, imagine you had the graph of, say, y equals 7x. Minus 1, you know that when x is 0, y is minus 1, and every time y goes up by 1, or sorry, every time x goes up by 1, y goes up by 7. So that's going to be up to 6 there, and so on. And that's what the sequence is doing. Every time the term increases by 1, remember n is 1, 2, 3, 4, 5, 6. Every time n jumps by 1, the term jumps up by 7. So an increase of 1 in the term number causes an increase in 7 of the actual term. So that's what the 7n is all about. And the minus 1 is effectively, it's very similar to what would have been a y-intercept. So if n was 0, what would the term be? And that works for any linear sequence. That's the method I'm going to be using over the next 3 examples.